Well, hello everybody, and welcome again for joining us for another OpenShift Commons briefing. Today we have one of my good friends, Marc Boorshtein from Tremolo Security, giving us our last OpenShift Commons briefing of 2018. It's been quite a year. We just came off KubeCon, and Marc and everyone was there, so it was great to catch up with him there. But we're really pleased to have him again talking about securing OKD, in other words, OpenShift open source version, which has been renamed recently to OKD from Origin. If that looks unfamiliar to you, you can go to okd.io and get all of the same stuff that you ever got before. We just renamed it. And I'm going to let Marc introduce himself and take it away. We'll have live Q&A at the end if you have any questions. And this recording will get posted on YouTube later this afternoon. So take it away, Marc.
Thanks, Diane, and thanks again for letting us come on and share our experiences here. So we're going to be telling two stories in this presentation. The first is looking at security at multiple layers in OKD. So a lot of times folks will talk about container security, or they'll talk about the authentication process. We're going to look at from the host all the way up to the container. And vice versa. So we're going to look at that from multiple layers. And then the second story we're going to tell is accessing Windows resources. One of the things that makes this customer so interesting is that they are working in a legacy Windows world. They have information that's locked up in Windows resources. And so marrying the cloud native ideas in OpenShift with the legacy world of Windows. So we're going to be telling both those stories. So real quick, who are we? Tremolo Security, and what do we do? So our slogan, Cloud Native Identity Management. And so what that means to us is that we're small, we're lightweight, we're dynamic. You'll often find us spending a lot of time in Kubernetes and OpenShift communities. We also have integrations with popular content management systems, so WordPress, Drupal, SharePoint, pretty much any application you can think of, we've probably done integration with it, .NET, etc. We also integrate at the system host level and the infrastructure level, where we're going to be talking a lot today. And so if you check out our website, we've got a lot of great integrations there. So let's get into the fun part. What were the goals of this deployment? So this is a customer case study. This isn't a theoretical, what could we do, how could we do it? And so this is an implementation that's running in production right now that really pretty interesting. They wanted to run a package that was not originally designed for containers, but they wanted the benefits of containers. And one of the things that was really interesting about this is that this package, all of the source data came from Windows resources. So Windows file shares and SQL Server databases. And so the first thing they wanted to do is they wanted to authenticate with Active Directory. Which too exciting. By the way, if you're not on mute, could you kindly do so? Authenticate with Active Directory, that part's easy. They want to externalize authorization. So the people who manage and own Active Directory are not the same people who manage and own OpenShift. And so they didn't want to start polluting their Active Directory with information specific for OpenShift. They want a secondary place to store authorization data. And then when they access CIFS and SQL Server, they had to do it as the user running the application. So as I, Marc Boorshtein, am going to log in and do some work, and my applications are going to start talking to these CIFS drives, CIFS has to think that it's Marc. It can't be a service account doing it, and that's needed for compliance reasons on their end. And then they wanted to have Kerberos aware pods. They didn't just want to have to inject credentials into an application. They wanted the pods to actually know that they were running with Kerberos, and so that things like Python scripts that they were building that were going to talk to SQL Server would just work out of the box. And then finally, self-service. people didn't want to have to do all this manually. And, of course, everything needs to be done securely. So we started off talking about layers of security. A lot of times folks talk about authentication. But you always want to have multiple overlapping layers of security. So that way, if one layer fails, there's something to back it up. So at the network side, you're talking about firewall, right? At the front door to OpenShift authentication. Then you also want to make sure that folks that don't have access to certain resources can't get to it. So you have authorization, and then where the coarse-grained ability of Kubernetes RBAC solutions fail or aren't fine-grained enough, now you have a tool in admission controllers. There are more details that we're going to talk about here. So OpenShift provides things like SCCs. So that gives you the ability to define what your pod can do. For instance, if you need to have access to the host or other things. So there are multiple layers that we're working with. And then this doesn't just apply to OpenShift, but it applies to the entire infrastructure underneath, which we're going to get into. So let's start diving into code, or not code, architecture. So on the left here, we have OKD, which of course is a bunch of VMs running software. And then on the right, we have our Active Directory and our file server. So we have to make these two things talk. And so because we're talking about Kerberos, we want to have host level security. We decided to go with FreeIPA. So if you're not familiar with FreeIPA, think of it as Active Directory for Linux. It's a tool from Red Hat that really makes bridging the Linux and Windows world much, much easier because it takes care of all of the kind of nitty gritty of Kerberos trust and things of that nature. It also has some really great features of being able to extend Active Directory users into your Linux environment without making changes to Active Directory. We made really extensive use of that. And so that was the first decision we made, was to when we built out our OKD infrastructure, we're going to do so with FreeIPA, and we're going to set up what was called a domain level trust. That's a default trust between Active Directory and FreeIPA. And so that means that users from Active Directory can log into your Linux resources, but users that are built inside of FreeIPA only in your Linux domain don't then have access to Active Directory. So this kind of gives us the best of both worlds. Users from AD are able to log in, but there's no backwashing into Active Directory. Everything stays isolated. So now the next question that came in was, how are we going to orchestrate all this? We wanted to have a place where we could store authorization groups, so FreeIPA is a great choice for that. But we need to be able to do authentication. Now, OKD can do authentication with AD out of the box. However, we decided to put OpenUnison in front of that because the long-term goals were to go beyond LDAP authentication against AD. SAML was one thing that we've talked about. Everything, at least in my opinion, everything in OKD should be considered privileged access management. And so multi-factor is another thing that we talked about. And so injecting OpenUnison into the process early gives us a proxy layer basically to do that. The second piece was orchestration of FreeIPA. One of the things that's interesting about FreeIPA is there's a feature called a view, a user view. So the idea is that if I have a user in Active Directory that we need to add attributes to, but we can't inject them into Active Directory, FreeIPA will let us apply this view to it, where it'll store those attributes locally and associate it with the user. The part that made that a little harder, however, was that overlay doesn't get integrated through the LDAP layer. And so we added several features to OpenUnison to make this integration work a little bit better and a little more transparently. And so we added features that allowed us to run authorizations against external groups inside of FreeIPA. So that's what allows you to add a user from Active Directory to a FreeIPA authorization decision. And then we also added a code that would let us generate the IDs we need, the Linux IDs or the POSIX IDs really, out of FreeIPA, and then store them in this default view. So that way we had consistent access to the IDs. So by combining OpenUnison and FreeIPA, we really created a very seamless integration with FreeIPA. So then the next thing that we ran into was we wanted to be able to limit how, we wanted to be able to perform limits outside of just RBAC. RBAC's great, but it's not very coarse-grained. Once you have access to something at the API level, you can't then say that only certain aspects of that are available. And so Kubernetes and OpenShift has this great feature called mutating and validating webhooks to be able to extend the authorization process. And so there's a Cloud Native Foundation project called OPA, Open Policy Agent, that makes it really easy to build these types of policies. Now you'll see here that OKD is communicating through OpenUnison to get to OPA. That's because we needed to add some capabilities that OPA didn't have out of the box. And we felt that the easiest way to do that was to use OpenShift's, or excuse me, OpenUnison's built-in integration with OKD. So now we're just throwing a lot of architecture at you. We're going to step through the different functions, how they worked, why we did it, and how it all came together. And then, of course, a demo. So let's talk about keytab. So the mechanism that we wanted to use for having our applications inside of pods talk Kerberos was via keytabs for a few reasons. One, we didn't want to store passwords. That's just a really bad idea. Two, the customer didn't want to store keytabs as secrets, primarily because the assumption was that there would be more OpenShift admins than there would be IPA admins. And so they wanted to really limit the scope of how these keytabs get stored. So the process we decided to go through was to actually deploy the keytabs on each of our worker nodes. The idea being that it didn't matter which pod fired up, the keytab would be available, and then we're relying on host level security through IPA's host-based access controls to limit the access. So if somebody logs in, SSH is in, they might have access to their own keytab, but they wouldn't have access to anybody else's keytab. And so that's how we're limiting the access there. Then the question becomes, how do we distribute these keytabs? Well, this is where Ansible comes in. John Osborne came up with a great idea. I was chatting on Twitter trying to figure out how to do this. And he said, you know what, you could run Ansible as a pod in a job. And so that's exactly what we did. It was a great idea on his part. And so what happens is when somebody actually says, I'm going to deploy a new keytab, and just to define what keytab is, a keytab is basically a special file for your password. There's a one-to-one correspondence between your password and a keytab. If your password changes, you need to update your keytab. The big difference is that the keytab's not reverse encryptable or unencryptable. You can't determine a password based on a keytab. So if somebody were to compromise your keytab, they could do anything as long as that password is still valid that's based off of, but they couldn't reverse engineer a password from it. And so what we did was we actually built a process where I, as the user, can specify my password. We don't want admins knowing the password. Specify my password. OpenUnison will generate a playbook based on the nodes in the cluster. Will provision secrets, generate a keytab, provision the secrets, and then create a job that will run a Ansible playbook and distribute it across the nodes and make sure that it's up and running. And then delete everything. So everything's completely automated. So next thing that comes up is validating persistent claims. So because these persistent claims are CIFS-based and they need to be accessed as the user, we needed to make sure that we could figure out which persistent volume is associated with which user. And so we're doing that via annotation. So when the user gets access to the cluster, they're able to request keytab access. And then OpenUnison workflow engine will generate persistent volumes for that user for the CIFS drives. And so when we do that, I've got highlighted here, we actually mark the persistent volume as user only. So this means that only the user who is associated with this particular persistent volume is able to have access to it. And we're actually using a flex volume for this deployment to be able to do CIFS, because CIFS just isn't a first-class citizen in Kubernetes at this point. So we have this flex volume, and a flex volume is really just a shell script that knows how to mount drives. And it goes ahead and it knows where it's mounting. And then this is the UID number that comes out of IPA and the user's account. So that tells us everything we need to know to authorize it. So if anybody besides OC Commons 1 wants to claim this persistent volume, it'll fail. And it fails because we wrote into OPA how to authorize that. Now, the second thing that becomes interesting here is because the information we need to validate the request is in the persistent volume, not in the claim. Without the volume being in place, we can't actually validate the claim when it gets submitted. So we actually had to add a rule to OPA that says if you submit a persistent volume claim that matches a persistent volume that doesn't exist yet, we're going to reject it, because we have no way of saying whether or not that claim should work yet. Or after, okay. And so here's the thought process we went through with our deployment of OPA. OPA basically has two parts. It has a policy evaluation engine, often called Rego, or not often called Rego. The language that you write policies in is called Rego. And then it's got an internal database. Now, this internal database is ephemeral. It's not like a SQL Server database or anything else like that. It's really designed to be able to help you make easier policy decisions. And so in the case of Kubernetes, when you deploy Open Policy Agent, it runs with a sidecar that's constantly pulling in updates to Kubernetes objects. So we need to be able to authorize based on the persistent volumes that exist. But as we started testing, what we found very quickly was that when you deploy, most folks don't deploy pods directly. You deploy a deployment, and then you let the deployment configuration deploy the pod. The issue that we run into with that is that the request that gets submitted to OPA doesn't reference me, Marc Boorshtein, as being the user to create the pod. It represents a service account that the deployment is built using. And so we don't actually know who the requesting user is in OPA. So we needed to add some logic that said, okay, well, we're authorizing users based on their namespace, based on their project. And so users only have access to their own project. They don't have access to anybody else's project. And so it's safe to say that if you are in a project, you are either the user or you're authorized to run as that user. And there are going to be some specific use cases down the road where service accounts are going to be needed for specific reasons. And so we needed a way to tell OPA not only who the user is, but also we needed to figure out all of the different types of tokens that were needed. And we'll get into the details of that why in a moment. And so having OKD talk directly to OPA wasn't going to work. That's where we injected OpenUnison. OpenUnison, one of the things OpenUnison does is it's a reverse proxy, and it gives you the opportunity to manipulate a request as it goes downstream. And so we injected OpenUnison between OKD and OPA, and what that allowed us to do was to pull in information about the user. So if the user was submitting a deployment, it could actually pull the information out of the namespace annotations as to who the user is. And it could also pull additional group information out of and attributes outside of FreeIPA. OKD doesn't know that much about its users. It basically just knows a username and a couple of other bits of information and then groups. And so all the other information that we would need is coming from FreeIPA. And so that's also the opportunity we have to grab it. And then once we have that information, we're injecting it into the request, which OPA then knows how to parse out, and it works real nicely. And so we're using that on both validating webhooks and also mutating webhooks. So the next part is sidecars. So in order for us to run a pod that has access to Kerberos resources, you have to do a lot of things. You've got to get a keytab, you got to initialize it into a keyring, and that keytab has to be kept warm. And so I'll have a link in at the end to a great blog post that was written by a member of the OpenShift team on how to do these Kerberos sidecars. But you need a lot of information to do that. You have to have the Kerberos configuration, you have to have the user principal, and then you have to create that sidecar itself. And while the sidecar is not particularly hard, think about it from a developer standpoint. The less you ask your developers to do, the less likely you're going to get a support call. So what we wanted to do is we wanted to give users the ability to just add an annotation to their pod or their deployment, and just inject a sidecar. So if you're familiar with working with Istio, very similar to the same pattern that Istio uses. In fact, we ran into a lot of the same bugs in OpenShift, primarily in 3.9, so they've all been fixed, that the Istio team ran into when integrating into OpenShift. So if you see here on the left-hand side, the pod that we're going to run has this annotation here called sidecar. That annotation does several things. One, it tells OPA, hey, go ahead and inject the sidecar. But what it also does is it tells OPA to change all of the service accounts. So the way that we're doing this is we've got a volume mount that stores a local volume mount that stores the keytab, and we're using we're using SCCs to make sure that the pod only has access to that. And then, but in order to have access to that SCC, you've got to change the service account, and then everything falls down from that. The problem is that the mutating and validating webhooks run after the service account injection webhooks. And so what was happening was, even though we changed the service account, all the different tokens still point to the default service account. So we not only had to figure out what access the user needed, we also had to pull OpenShift to figure out what tokens were needed for the service account that we're running as. So run as OC Commons 1. And so that OPA process for importing data, we didn't want to apply that to secrets because that's going to import the entire secret, not just the metadata about that secret. So we're doing that at the OpenUnison layer, since OpenUnison already is a cluster admin and is able to interrogate the API server. So when you submit this pod or deployment of that pod, you get everything on the right side. And there's actually like 4 more pages, but I couldn't actually fit it all in. So I'll show it to you once we move through the deployment. So a lot of moving pieces. Speaking of which, here's the demo. So I'm going to go ahead and pop out. And we are going to start at Windows. So can everybody see me? See a Windows desktop?
Yep, looks good.
So this is our shared drive that we're going to work with, our L drive. There's nothing in here, nothing up my sleeves. And I'm going to go ahead and create a new user. And then shift, oops, shift commons, free OC commons. The brand new AD user doesn't have access to anything. Demo, we're not going to go too crazy about password policies, and so that I can receive emails for this user. And now I've got a brand new user. Let's come back here and let's fire up a new private window. First thing we're going to do is we're going to log into Scale.js. So this is the front end for the web services that OpenUnison provides. Creates a nice little portal for people to start with. As I log in, a couple of things are happening. First, obviously, we're validating our password against AD. But the other thing that we're doing is we're running what's called a just-in-time workflow, which is actually simulating a login to, or it's simulating a login to one of the FreeIPA hosts, one of the hosts that are part of the FreeIPA network, in order to generate the correct POSIX information for the user. We're then getting that information and provisioning it into IPA as a user overlay. And so you can see here that I now have a Linux UID number that if I were to log in to the terminal and type in ID, that's the number that would come up. And so as you'll see, I don't have access to anything. So let's change that. So we're going to request access. And so this is the self-service portal. And the mechanism that this customer wanted to get access, say, okay, when you get access to OpenShift, and I'm going to request access here, we're going to generate a project for you. Everybody gets their own project. So for OC Commons, I'm going to submit the request. Now I'm going to come back here and log back in as my admin user. So I'm now logged in. So I'm now logged in as an administrative user, so I have access to a lot more. I have access to the console. We deploy with an ActiveMQ integrated for high availability, and then to be able to deploy the keytab. So I have access to a lot more things, including the ability to approve access. So here's the request that just came in for OpenShift Commons 3. And it's going to load up the approval and say for demo. So when we confirm this request, several things are going to happen. One, we're going to create We're going to create a project for OC Commons 3. We are going to create groups inside of IPA for managing access to that project or for approving access to that project. We're also going to create all of the different artifacts inside of OpenShift. So we're creating the project itself. We're creating policy objects. We're creating group objects. And in fact, come over here to the reports and I go to single user changelog. In the report, we can see here the couple workflows. The first one was the just-in-time provisioning. So that was the creation of the account overlay, as well as the UID number and IPA. And then here's everything that we just created as part of our user and project onboarding. We created the project, we created the groups, we created the role bindings for viewers and editors, and then we also created, added authorizations for the user. So now I have a full environment that I can get started in. So I'm going to log out, and I'm going to log back in. Oops, there we go. And so now you'll see I've got a new badge, OpenShift console, so I can log in. And we'll see that I've got a couple of permissions here. I've got, inside of OpenShift, I've got a group called Administrators Commons 3 Project. That's part of the editor role binding. And then also we have the FreeIPA group Applications OpenShift. So that's how OpenUnison knows to authorize my access into OpenShift. And then if I go over to OpenShift, and you can see it's that blink there was me logging in. I'm logged in as OpenShift Commons 3. There's nothing in this project right now, but I'm going to head over here to storage. I have no persistent volume claims next yet. So now I want to be able to access Windows resources with my keytab. So I'm going to go over to request access, and I'm going to ask for keytab access. Wow. The request is being submitted. And now I'm my administrative user, Matt Mosley, so I'm going to go ahead and refresh. And we'll see that I have an open request here to be able to access file shares. I'm going to review that request and approve it. Now, before I actually hit the approval button, come over here. I'm going to show you our pods. You can see we have one here that was completed. We're going to go ahead and watch this happen in real time. So I'm going to approve the access. So for demo, that confirms. And my test rig is not the fastest machine in the world, so it's submitting now. All right, so I'm going to come back here to my console, and you'll see storage. I've got these two new persistent volume claims. These claims, so what that workflow did was it enabled my access for keytab, so it authorized me by adding me to a group inside of IPA, but it also created 4 new objects inside of OpenShift. It created persistent volumes to our L&R drive that are associated with me, and then it created persistent volume claims inside of my project. So now I'm able to access that data from pods inside of my project. But before I can do that, I need to deploy my keytab. So let's go ahead and log out and log back in. Now we're going to see that I've got a couple of extra things on my capabilities. I've got this deploy keytab badge. And then here, you can see I'm using FreeIPA. I can track who has access to keytabs. So this is giving us the ability to store group. FreeIPA is giving us the ability to store group information for Active Directory users inside of IPA. So we're not bugging the Active Directory admins for an OU or some kind of administrative credential. So I'm going to go ahead and deploy my keytab. Now let's come back here. So this is our Unison project, and this is going to go where we're going to see the Ansible job that's going to push our keytabs. So let me go ahead, put in my password. So when I hit save, it's going to validate the password against Active Directory. So it's kind of like logging in again. And then it's going to generate a keytab based on that password and distribute it to the nodes. That's running, and you can see that the workflow is already run and is creating our job. So now the great thing about this is the way it's set up is it's actually interrogating OpenShift for your nodes. So as you add new nodes, this just catches up with it. And so the user has been deployed, has been published. And so now we can actually start using Kerberos inside of our pods. So I'm back at our console, and we're going to show off a couple of things here. We're going to show off a pod that uses the CIFS, volume mount. We're going to fire up a version of Unison. Unison's one of our commercial products that we just said, okay, we're going to use the CIFS volume mount for storing files. And then we are going to show off our ability to run a keytab inside of a container. So real quick, first, show you there's nothing up my sleeves. This is our L drive. There's nothing there. Go ahead and come here. So we're going to start here. So this is the Unison pod, and we're going to add this annotation that says this is a CIFS pod. So OPA is going to see this and say, all right, I know that I need to add a couple of bits of information in order for the persistent volume claim to work. And then here's our persistent volume claim. I'll up it to Commons 3 because this is dry run 3. And so the second piece that'll happen is the claim against persistent volume claim 3, the L drive against the persistent volume claim that we're naming here is linked to a persistent volume. We're going to make sure that we have access to that to be, or we've already actually validated that access. So when the claim got created, so that has already been decided. So then what we're going to do is just inject the information we need to make sure that the claim is accessible. So let's go ahead and add to project, import YAML. Now I'm doing this as a pod. If we did this as a deployment, the big difference would be that instead of getting a request as the user, you'd come in as a service account, and so OpenUnison would then say, okay, here's the user who's actually requesting it get created based on the namespace. And so that little delay is because OKD is talking to OpenUnison, OpenUnison is talking to OpenShift. So now we're going to go take out our pods, and there's an error. The reason for that error is because it can't talk to that directory. So let's go ahead and enable access on the Windows side. So this is how you know that it's actually accessing it as the user. So we are going to add access. See, Commons 3, we get full access. And since I didn't do this as a deployment, we're just going to go ahead and delete this. And give it a moment. Or two. There we go, no pods. So let's go ahead and create our pod again. So again, there's a little delay here. Now it's firing up, running, and I bet when we come back here, you can see in real time, it's actually copying things in and the pod's firing up. And then if we come to this pod, go ahead and take a look at the YAML. So here was our annotation that told OPA, go ahead and inject CIFS. And so in order to do that, we actually have to run as the user because if the users don't line up, the pod has to run as the user. So it's running as OC Commons 3, which means we had to create a custom SCC, and we had to inject that into the pod. We also had to add We also had to add a couple of things here. We had to update the pull secret since we're running as the user. And then we also had to add information for the persistent volume claim for all this to work. So that's now a pod that's able to access the drives. The next pod we're going to do is the keytab injection pod. This is a pod that is actually not going to do anything, but let us show that we have a running keytab. So again, we took the great article that was written about injecting Kerberos into a pod and said, okay, let's make sure that we make it foolproof. So no adding of sidecars by user. So here's our pod, and import it. And then this is really the key here is this annotation. We're going to see that this annotation's there and go ahead and do the injection. You'll see there's only one container in this pod. I'm going to do the create. And it's creating, but you'll see here we have two pods running, containers running in our pod. That's because we have a motorcycle and a sidecar. The sidecar is where all of the work's being done of initializing the the key ring, and then sharing it with the keytab via shared with the motorcycle via shared memory. So our stuff runs in this motorcycle. Kerberos is managed and maintained in the sidecar. If I come over here to my terminal, I've got my sidecar and I've got my motorcycle. If I do a K-list in my motorcycle, there's my key tab. I am logged in as OC Commons 3. So as that tab needs to get reinitialized, or the keyring needs to get reinitialized, my motorcycle, where all the work's being done, or my sidecar, where all the work's being done, is doing that. So, okay, good. We've got some time for questions. I saw them keep popping up. You know, kind of where do we go from, you know, the first question you might ask is this all open source? Most of it. So we wrote a bunch of code that was specific for the customer around creating key tabs. We're going to work with them to see if they're open to us releasing it as open source, or potentially we'll do a clean room re-implementation. So that way it's all clean and license free, because we could definitely see other folks really being interested in this. Besides that, everything is available. So all of the code that we wrote for interacting with OPA and injecting additional information, and I'll have links to that here, that's all open source. OpenUnison is open source, and obviously OKD and OPA is all open source. Windows, obviously, not open source yet. Not sure if anybody from Microsoft's on the line. See where that goes one day. So yeah, so that's everything from the demo standpoint. At this point, why don't we open it up for questions?
Okay, so Pranav has asked a couple of questions here, and you may have sort of covered it in what you just said, but what is the support for enterprise OCP for this product?
This would work just fine with OCP. The customer themselves decided to go with OKD, which is why we're talking OKD here and not OCP.
And a similar question, I think you answered it too, but we'll ask it again. Tremolo secured a separately licensed product. What's the license model, et cetera?
So that's a great question. So we have two models. We're an open source company, so all of our products are open source. We have a commercial version, which has a nice management UI. That makes it a lot easier to build a lot of these policies. It really cuts down the amount of time to do the implementation. And then we have OpenUnison, which has all the same features and functionality. You just got to configure it by hand. And so we're actually using both on this particular deployment, which is really cool. This is the first time we've done that, where we're using the Unison management UI to build everything. And then we do an export of the code into a Git repository, and then we're using our S2I builder that we built to create a hardened undertow image based on that config. So we're using the GitOps style that folks really like with OpenShift, and we have the management UI for managing really certificates, key stores, and networking config. So if you want to go the Unison route, that's one potential license. And then if you want to use the OpenUnison route, of course, it's open source, 100% free. And go ahead and get that on the screen here. But we do also commercially support it. So we've got customers that will run the commercial version paid and the open source version paid. And then we also have right now it's called the OpenUnison Quick Start, but we're actually moving that into a new GitHub repository. So that portal that you saw, being able to request access to OpenShift resource and stuff like that, we have a baseline that just works out of the box. It doesn't give you everything that you saw around Kerberos and whatnot, but that baseline functionality is there. And then we also we got a lot of requests at KubeCon talking to folks for a SAML 2 version of that just only did SAML 2 authentication for OpenShift. So that's going to end up in this OpenUnison GitHub repository soon as well.
All right. Thorsten, I unmuted you if you would like to ask your question. He may have answered it. Let's see. Give him a second, see if he realizes he's unmuted. Not hearing from him. So there's one last question from Pranav again. Where can we get the documentation to implement this and integrate with OCP OKD?
So that's kind of a bit of a work in progress. The version that this is built on hasn't been fully released yet, in the sense that it's still being documented in QA. Part of open sourcing a lot of the custom code is also going to involve documenting it. And so that will be coming slowly but surely. But if you're interested in implementing this, I'm more than happy to kind of talk to anybody offline about some of the details as well. So some resources on documenting this. OpenUnison has a lot. Every feature is documented. How they all fit together isn't always documented as well as I'd like it to be, but every switch is there. FreeIPA, the Open Policy Agent, and if you're working with Open Policy Agent, join the Slack channel. It's got a great community. They love to help out. I would not have been able to do this without the great help of the folks on that channel. Excuse me. And so lots of thanks there, and they're a great resource. And then, of course, the link that I mentioned about running Kerberos inside of a sidecar.
Well, I think that might be all the questions we have today, and I just wanted to thank you very much. Please do connect with Marc. He's always on our Slack channel in OpenShift Commons, and if you're not there yet, just go to commons.openshift.org and join up, and I'll add you to the Slack channel itself, and you can always reach him at Tremolo Security. And as I said earlier, I will post this and his slides shortly this afternoon, and hopefully maybe what we can collaborate on is some more documentation, as a lot of this is all open source project stuff. So if you have feedback and there's documentation missing, that's always an opportunity to help out building out that documentation. So we look forward to hearing more from you in the new year and more case studies. And thanks a lot, Marc.
Yeah, thanks for having me. And a little bit of shameless self-promotion. If you are in London at the end of January, OpenShift Commons, we are going to be there as well. And so would love to talk to you.
All right. Yeah, we are on January 30th. We'll all be in London at the Savoy Place for a day of OpenShift Commons talks and lots of more case studies, as well as a number of updates on OpenShift 4.0. So also go to commons.openshift.org and you can find all the details there on the upcoming gatherings. So thanks again, and Mark, email me your slides and we'll get it all up today. All right?
Fantastic. Thanks again, Diane.
Thank you all. Take care, guys.